Welcome back to CAD/CAM tutorial. In today's tutorial, we are going to create an air motor or pneumatic motor in SolidWorks. Here we will create each and every part and assemble at the end. This is a simple air motor. Air motor works with the help of compressed air, which converts the air into mechanical energy or simply create a torque and rotational motion. And this is a simple, it can generate a small amount of torque. So let's see how to make this simple air motor. Let's make the first part of pneumatic motor, base plate. This is 82 by 50 millimeter and the thickness here see 16 millimeter. Okay, then there is a 4 number of holes with tapped hole. See, this is M4 tapped hole. Thread length 16 and the hole length is 8 millimeter, and the location of this hole 38 by 25 millimeter, and the corner chamfer 1.5 into 0.45 degree. So here let's say top plane sketch. Let me choose center rectangle and 50 tap 82 enter. Now simply go to feature and choose extruded boss bit. Keep end condition blind and thickness 16 millimeter or say depth. Again I'll choose, okay, now let's directly go to hole wizard. Here you will see straight tap, DIN standard tapped hole. If comes down M4, here keep blind, length 8, whole length is 8 millimeter, but here thread 6 millimeter. Position, click on this. Let's place 4 location somewhere. Okay, now let's hold shift key, create relation, vertical, this two vertical. Now okay, horizontal. Now let's define first this 2, 38, 25, but this is located at center. So what we will do, we will define one center line, a construction line, hold shift key, select these two and lines, make relation symmetric. In the same way, select this one and center line, symmetric. See, this is fully defined sketch. Let's check here, we by mistake write 8000. This is only 8 millimeter, say yes. Chamfer 1.5, I'll choose all 4 edges. Yes. Now let's select, go to appearance, and here you will find option in appearance, wood and oak. That's it. Go to option, documents property, detailing. Click shaded cosmetic thread. Now you will see the thread, cosmetic thread is easily visible. Let's save this one, desktop. Now create a folder, pneumatic motor. This is part 1, so let's say base plate, save. New part, okay. Now here part 2 is mounting bracket. 48 outer length, 16 millimeter upper length and 24 millimeter internal length. Thickness 2 millimeter. And how long we need to extrude? 35 millimeter. Corner radius, inside radius R1. Okay. Then there is one cutout 14 by 4 millimeter. Okay, then we will use some, let's finish this front plane sketch, and I'll choose your line. Okay, I'll start from one end. Now I'll choose these two lines, two relation, collinear and equal. Distance 48, 16. $24. Now go to sheet metal base flange. Reverse. See, it's moving upside. Thickness 2 millimeter and radius, corner radius, inside radius become 1 millimeter. Again click edit. The blind condition or end condition 35. Okay. Top sketch. Let me choose corner. I'll connect from here to here. This is cut out 14 millimeter. Extruded cut, and the depth here is keep end condition blind 4 millimeter. Say yes. Now look. Select this face, hole wizard. Now simply choose your hole, DIN, dowel drill size, (4 millimeter). Now let's see, there is a 4 millimeter hole, 25, 38, 8, 16. And hole select through all, position. Okay, 1, 2. Don't create any relation, otherwise it makes difficult while creating. Escape to out. Now first make this 2 and find out any mid plane. Okay, make one vertical. That's it. Vertical. Vertical. Horizontal. Because these outer 4 are in main symmetric dimension. (25), 5 millimeter from here, 38 millimeter. Now this one, first one is 8 millimeter, the second one also 8 millimeter from here. Okay, it's by default. It is also by default. Okay, the dimension balance from here. It's 5 millimeter. Now the drawing is fully defined. Yes. Now look, the hole and everything is fully defined. Go to appearance, metal, brushed chrome. Say part number 2, mounting bracket. Let's go to part number 3. Part number 3 is main part, it is block. Now you will see the block. We will start from this point, this position, this 40 millimeter, this tapered is 38 millimeter, overall length 62, 21, and the width or thickness is 20 millimeter, and this one is 12 millimeter. So let's say front plane, sketch, line, and let's start like this. Taper and connect. Vertical. Let's define. First, overall length 62. Distance from here to here 40. 12. 38. 21. Okay, let's see what else balance. Okay, this 30 is balanced. Then there is some holes are here. Counter bore hole, a piston hole, 14 millimeter. This is 10 millimeter away from here. Then there is one cutout also like this, 2 millimeter thick, 4 diameter, and 24 millimeter from this end. And there is 4 number of tapped hole, M3, 6 thread, 9 length, and this is 14 millimeter, okay, 3 millimeter, 24, and this length, okay, let's try this. Now this is fully defined. Extrude. Now here keep end condition mid plane 20, so that it help us to create. Okay, now let's go to top face, sketch. Let me draw center line. Circle. Here one 14 diameter circle. Okay, now one 4 diameter circle. Let me connect. Now select these 2 lines, click mirror entity, it is mirror. (10 millimeter). Now this distance 24 millimeter. Extruded cut. Now this portion, click through all. Okay. Again select the same sketch, extruded cut. This time select this. Exit. Extruded cut. In selected contour, choose this. End condition blind and depth only 2 millimeter. Say yes. Hole wizard. Go to again straight tab. Okay. Sorry. Tabbed bottoming hole. 3. Uncheck this collar thread cutout. Position. Click this one. Now let's place in 4 position. First create relation. Okay, this is already vertical. Horizontal. Let's define this. 3 millimeter, 14 millimeter. If 14 means from one side, it is also 3 millimeter. 24 millimeter. Say yes. Go to here, documents, property, detailing, click shaded cosmetic thread, yes. Now let's make one counter bore hole. This is length 30 millimeter and this is located at the same position. Upper diameter 4, 30 millimeter long. This is counter bore hole and diameter, and the real hole diameter is 2.5. This is also 2.5. You will see here 2.5. And here we need to make one more hole. This diameter 8 and this is 10 millimeter from bottom line. Then one hole here in opposite side. This is 20 millimeter to 5 millimeter. Let's make this hole 5 millimeter, 8 and this 20 millimeter. Extrude and keep end condition through all. Okay, now let's this face. Now here 8 millimeter hole and this hole also 10 millimeter. Make sure it is in located center point, vertical relation. Extruded cut and keep end condition here through all. Say yes. And at this end we found a chamfer 1 millimeter into 45 degree. See. Hole wizard, go to here, legacy hole, counter bore. Now the main diameter (2.5), length keep as it is. Counter bore diameter it's 4 and the length 30. And here keep end condition to next. Because this hole already we created, go to position, click on the top face and move your cursor and find out center point. Escape key to out and just rotate and see how it's going to create up to this hole. Look, section view. Okay, now look how the counter bore hole is created. Now at bottom there is two hole, 8 by 8, and this is M4 hole. This is also a kind of tabbed hole. Then there is one more hole and it is 2.5 millimeter from this position. Then there is two more holes, 6 millimeter, 17 millimeter and 3.2 millimeter. This face, (3.2 millimeter). Now select this two mirror entity. Now this gap is 6 millimeter. Now let's make the vertical length is 17 millimeter. Go to feature and select extruded cut, and in extruded cut keep end condition next. Say yes. Now see, it cuts up to the wall. Now hole wizard. Now here we need to make straight tap, DIN, tapped hole, and this is M4. We will keep 2 next. Uncheck this thread collar, and even though we don't need this, position, dimension. Let's make the dimension 8 and dimension from outer edge also 8. Hold shift key, select the center point and origin point horizontal relation. See, this is fully defined sketch. Say yes. See, the tabbed hole is created up to the, let's make, okay, let's create appearance. I'll use this color. Now section view. Now here we need to create one more hole up to here, and that is 2.5 millimeter. Okay. Click this face, sketch, circle, and make diameter 2.5. Okay. Now extruded cut and click up to surface and select this one. Now let's say section view. Okay, that's it. Now these are the holes for air inlet, and this is the passage which reach the hole to the cylinder. Part number 3, motor block. New part, cylinder head. This is 28 by 20, thickness 3 millimeter. Then again there is a M3 tabbed hole, 3 millimeter from this end, 1421. Top plane sketch, center rectangle, 20 tab 28. Extrude, keep end condition blind and 3 millimeter. Hole wizard, go to same straight tab, tabbed hole, keep here 3 millimeter. End condition next or through all, it's up to you. Escape. Now first make relation and keep in proper constraint for this. (14) 21. (3 millimeter). And from here to this end also 3 millimeter. This is okay, thus not yet fully defined. I think some relations are balanced. Vertical. Now this is fully defined. Okay. Hole wizard. Detailing shaded cosmetic thread. Now here you choose select body, this color, or let's say keep little light color. Part number 4, cylinder head. new part. Okay, now let's make the next part is flywheel. 50 millimeter diameter and thickness, if you see here, 10 minus 1 is 9 millimeter. Then there is 4 number of holes, this diameter 10, the pitch of this circles 24, and there is center hole 8 millimeter. This is throughout hole. Okay, then 12 millimeter we will extrude 1 millimeter, and from back side 36 diameter hole and cut 4 millimeter. Front plane is sketch circle 50 millimeter. Okay, 24 millimeter, make sure it is for construction purpose. Again select circle, this is 10 millimeter. Go to circular pattern and 4 number of patterns we need, equal spacing 4 number of patterns, say yes. Fully defined sketch, calculate. Okay, this is fully defined sketch. Okay, one more circle at center and that is 8 millimeter. Extrude, and this one extrude 9 millimeter. Back side sketch circle and keep diameter 36, and this is what we are going to cut. Feature and select extruded cut and make the depth here 4 millimeter. Oh, look, sketch 12 millimeter. We want to extrude it. Select inside circle, convert entity. So no need to again draw. Extrude and 1 millimeter only. Let me draw color. Okay. I'll use black color for this. X and feature also I'll choose this one. Okay. Now I'll select this extrude feature and metal. Okay, that's fine. It looks better, premium. Flywheel, save as flywheel. New part. Now the here next part is crankshaft. 34, 8 diameter, 12 diameter 4. Okay, chamfer 0.5. Then there is one hole. This hole is 3.2 and 14 millimeter long. Extrude 32 millimeter. Make it reverse. Okay. Select back, sketch, circle, and this is 4 millimeter actually. And extrude this one 12 millimeter only. If you select outer edge, you will see option chamfer 0.5 into 45 degrees. Say yes. Hole, I'll go to hole, simple metric hole, drill size 3.2, it's 3.2. Blind, length 12, it's 14 actually. Position, select this, select center one. Say yes. Now look, the hole is created. Okay, this is 34, we make 32. Okay, we will correct it. Then we need to make this cutout also. This cutout, see 1.5 millimeter this length, 12 millimeter width, this is 4 millimeter width, 11.5 millimeter from this end, 9.5 millimeter from this end. And there is one cutout hole also. This is 3 millimeter actually. If I'll choose the bigger length, directly edit 34. That's it. Right plane, sketch, corner rectangle, 1.5 tap, 12, 1.5 tap, 4, enter. Select this one and this one, collinear relation. Something went wrong, so just go back. Collinear, that's it. .5 millimeter. Select here extruded cut. Keep end condition through all bolt. Say yes. Select this one. Here we need to make a hole. And that is 3 millimeter hole. Up to next. Position. Now how to define the position? So let's make a center. Click on this point and you will get back your, okay. Say yes. Okay, let's see the section view. Okay, now look, this is how our section view. Let's do material brass. Okay, this 11.5 was the distance. Okay, that's everything fine. Crankshaft. Once we save crankshaft, then we will move the next part, crank. 11, 15, 4, 8 millimeter from here to here, inside 8 millimeter, and this one also 4 millimeter. Thickness 6.5, and this one 11 millimeter. Okay. Crankshaft. New part. Next part is crank. Okay. This hole. Now this diameter 11 millimeter. Let me choose one more circle, and this radius or diameter 8 millimeter. Then inside there is one circle 4 millimeter. Center point arc, exit Now let's click this two end point horizontal line and connect to here, and same connect this point to here. Okay, let's define this. This radius 15, vertical length 4 millimeter. Eight millimeter. Let me choose line. Connect from here to here. Okay. Mirror entity, let me choose this line, mirror line, say yes. Now, okay, so there is one more hole at center and that is 8 millimeter. Okay. Trim entities, power trim, and let's trim this part. That's perfectly defined. Extruded boss base 1, 2, 6 millimeter. Keep mid plane so that it help us. Okay, again choose the same sketch, extruded boss base, this time comes to here, 6.5 mid plane. See, actually no, we don't need mid plane for this. But we forget to add something to surface face. Start from back surface. Say yes. Now look, it's 0.5 millimeter away. So this is the way you can handle it. Okay, let's save this one. Part number 7, crank. Let's make a new part, and that is connecting rod. 35 millimeter long, 8 and 4 millimeter, 6 and 3 millimeter, radius R8, thickness 8 millimeter. This crank web is 6 millimeter and thickness 3 millimeter. So let's see, top plane, sketch. Okay, hold shift key, select the line, midpoint. That's also fine. Now let me choose here 8 millimeter, 6 millimeter. Let's make the dimension 35 millimeter. Now let's hold dynamic mirror. Select this one, this line as a midline. I'll choose here line, 6 millimeter, enter, exit. Make sure this line is horizontal. In the same way, I'll go from here and I'll define this line also 6 millimeter. One more line I'm going to take, connect, horizontal, click again line, go back to the point and see it's going to convert into arc. Four, 8, 8. See, this is fully defined. One more thing is balance at center radius. Okay, 3. Let's finish. extruded boss base. We need to choose because there are too many closed geometry. 3 millimeter mid plane, okay, because this will help us. Connecting rod. The next part is piston. Now just note down the dimensions. 7 millimeter the one side length, 6.25 millimeter. This one there is a step 1 millimeter. If it comes down, there is a this kind of a step. This is also diameter 6.2, and this inside one is 4.75, and this length 11 millimeter. Okay, this angle given 20 millimeter. Then there is one more angle 59, and there is one hole 3 millimeter, and this is located at 7 millimeter. Front plane is sketch, center line. Let's start with line. Connect with this. This is okay, and one more closed geometry dimension. Seven millimeter, .25 millimeter. Then overall length is 15 millimeter. One millimeter. .25, .75 millimeter, and let me define this angle. 20 degree. .59 millimeter. Okay, let's do one thing. Connect this one with this. Now this length from here to here is 11 millimeter. Now our drawing is fully defined. Revolve boss base. Line, see this vertical line selected as the axis of revolution, blind, and angle 360 degree. Yes. Front plane is sketch. Let's make a 3 millimeter hole, and from bottom edge is 7 millimeter. Shift and make constraint extruded cut. Keep here end condition through all both. Say yes. Let's define a green color so that it looks piston. Let's make a new part, and this is crank pin. 13 millimeter long, 4 millimeter diameter. Then after 10 millimeter there is one cutout, and this is 3.8 millimeter. Okay, 2 millimeter this is balance. 0.45 is the chamfer. Front plane is sketch. 4 extrude, end condition 13 millimeter. Again I'll choose the same sketch, same face what we 3.8, and this time I'll select extruded cut, but length I'll keep 1 millimeter, but start offset 10 millimeter reverse. Look, it's going to be here, but we forget to edit. Click here, flip side to cut. Now see, chamfer, and I'll choose this edge. Look, this is part number 10, crank pin. The next part is piston pin. 13.5 millimeter long, 0.2 millimeter is the chamfer, and 3 millimeter is diameter. Three millimeter extrude. 13.5 keep end condition mid plane, which help us. Chamfer 0.2 and select this face. Say yes. Okay. Save this one. Piston pin. Now here the last part is washer. Six millimeter, 3.5 and 1 millimeter. Front plane is sketch 6, 3.8 and extrude 1 millimeter. Okay, now let's make appearance like little dark. Save. Washer. Now let's start assembly. How you will do? Make assembly from part. Now the first part is base plate. Click here and the base plate will appear. Okay. Insert component. Where is our second part? Mount bracket. Bring here. Click mat. Select this hole and this hole. Concentric relation, yes. Just rotate this hole and this hole. Concentric relation. Make sure this hole and this one. Concentric relation. Bottom of this and this one. Coincident relation. Say yes. Now look. Insert. Now this time we will bring flywheel, hold shift control key, crankshaft. Flywheel, crankshaft. Okay, we need a housing, motor block. This is important part. Rotate. I'll keep like this. Mat. Just take in proper position. I'll select this hole and this hole. Coincident, concentric relation. Okay. Just take up this hole and this second hole, concentric relation. I'll choose bottom face and this face, coincident. That's it. Now click on this, change transparency. That's it. Met. Select this hole, concentric relation, drag here, flywheel and crankshaft, concentric relation, okay. Select this face and this wall, coincident relation, but this is still moving free, okay. We need to make it free movement. This one, flywheel. Let's see any one plane, top right plane, comes down, crankshaft. Hold control key, right plane, make met. See, is going to fixed here. Okay, cancel. Because if I am going to rotate crankshaft, so flywheel also rotating. Now let's insert the next thing here, crank. Now here bring some more component like piston, insert component, connecting rod, piston pin. Let's make relation between this piston pin, front plane of piston pin, go to piston, hold control key, front plane, see is going to match, okay. Again one more relation, select this hole and this pin, concentric relation. Oh. Now this rotate, okay. Pin and this hole, concentric relation. Now again we need to create a mid plane relation between pin and front plane of pin, comes down, connecting rod, and we need to find out which one is the hold control key, top plane, coincide. See, it's going to fix on this, okay. Select the motor block, hole, piston, okay. Let's move inside. I'll select this one, cancel it. First let me rotate this one. Met, concentric relation. This hole and this hole, coincide relation, concentric relation. Parts, and here we will use crank pin. Met, this pin and this hole, concentric relation, this wall and this pin, coincide. insert component and let's say washer. Met this hole, concentric relation, this wall and this one. Control key and create one more. Just control key, click and drag and you will get one more. Met hole, concentric relation. I'll choose this wall and this wall. Coincide relation. Okay. Now select this face and this face. Concentric relation, coincident. Now almost we fixed our geometry. Okay, this is still rotating. Met this face and this face. Coincide relation. Now let's try again. But this is not rotating with this body. Okay. So let's hide. Let's make this one and this one. Crankshaft, right plane. Okay. Now comes down crank. Control key, right plane, met. It is going to met here. Say yes, okay. Now see if I am going to rotate crank, see the whole body going to rotate. So this is the main inlet for air. This air will pass through from here and this will come at the top and push this piston to downward, and this is the exhaust of hole, and with the help of compressed air this engine going to move, and flywheel will help, and we can give a rotational revolution to any mechanical part. It's create a small amount of torque, but it can. Cylinder head, met. Okay. Concentric. Okay, this face and this face, coincident relation. Okay. Okay, that's look perfect. Now let's say add some more bolt. Go to toolbox and here you will find option DIN, bolt. Now here we will add 215, drag to this bolt we will add M4. This one thickness 8 millimeter because 6 millimeter we need to make depth. Okay. Just move your cursor, click. Simply move your cursor and face, click. Move. Okay. And here also we need to fix. See, inside also we fixed. You will see how it's going to connect up to here. Now that's okay. Now look here, we have DIN M12 M3 12 millimeter bolt, and here it's 4 number of holes bolt. So again go to the same socket head DIN 12. Let's click here, drag and drop. This is M3 length 12. See, it's going to fix up to the end of this. Say yes. Now again go to hole and click OK. Now here we forget one relation, this one, met, coincide. Okay. Now let's save this one. Save, right click and click here motion manager, go to motion study. First I'll define, let's say 50, keep here animation and drag up to 10 seconds or something like this, and I'll choose this one, motor, and I'll select this hole and 50 revolution, say OK. Now click here calculate. Once you click calculate, it's going to calculate. Now once we finished, just simply play. Now see how it's going to air motor or pneumatic motor works. The air inlet from here, the air passes through these patches to the top of the piston, then it pulls down the piston, and simply we can create a mechanical energy with the help of compressed air energy. It creates a small amount of torque, but it can. So this is the simple pneumatic motor or air motor. I hope you like it. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.